Right now, somewhere beyond the orbit of Jupiter, a piece of ancient starlight is going dark. Not literally, not in the poetic sense, in the sense that matters to engineers who have spent the last year of their lives pointing every instrument humanity has ever built at a single object, and are now watching that object slip past the edge of what those instruments can see. Its name is 3IR Atlas, and the signal coming back from it right now may be the last one anyone gets. I want to be precise about what that means because this is not a story that needs exaggeration to be extraordinary. 3I Atlas is not malfunctioning. It is not broken. It never had a radio. It never sent us anything in the way a spacecraft sends data. What it has been sending for the better part of a year is light. Reflected sunlight, scattered off a nucleus in a coma made of ice and dust that formed billions of years before our sun existed. And that light, read by the most sensitive instruments ever placed in space, has been the closest thing to a voice this object will ever have. Now, that voice is fading, and once it fades past the point where James Webb, Hubble, and the spacecraft still watching from Mars and Jupiter can resolve it, there will be nothing left to read. No second chance, no follow-up mission. Because nothing we have built can catch something moving at 250,000 kilometers an hour on a trajectory that ends outside the solar system forever. Stay with me, because this is the last chapter of a story that started in a desert in Chile, and it deserves to be told with the weight it's earned. To understand why the fading of this signal matters, you need to understand what 3I Atlas actually was, and why it was never going to stay. On July 1st, 2025, a telescope in the Atacama Desert caught something moving across the sky that did not belong to our solar system. Not born from the same disk of gas and dust that built Earth, Mars, and every comet we'd ever cataloged. It came from another star system entirely, ejected billions of years ago, drifting through the dark between galaxies with no sun to warm it, until its path curved by pure chance, close enough to ours for us to notice. Scientists designated it 3I Atlas, the I for Interstellar, the 3 because it is only the third such object ever confirmed in recorded human history. And unlike the first two, this one arrived at a moment when humanity actually had the instruments ready to look closely. James Webb found methane in its coma at a ratio 11 times higher than anything ever measured in a solar system comet. Carbon-13 signatures suggesting it froze at temperatures colder than anything in our own outer solar system. A radiation-age surface consistent with an object between 10 and 12 billion years old. Older than our sun, older than Earth, older than almost everything else we have ever directly measured. It passed closest to Mars on October 3rd, 2025. It reached perihelion, its closest approach to the sun, on October 29th and 30th. And then it began the long climb back out, past Venus in November, past Earth's orbital distance in December, past Jupiter in March of 2026, and now in the summer of 2026, it has crossed a threshold that very few people are talking about, but that every scientist tracking it has been quietly dreading since the day this mission began. Here's the thing about comets, especially ones this old and this strange. They are only visible because sunlight warms them enough to sublimate their ices, producing the glowing coma and tail that our telescopes can actually detect. Move an object far enough from the sun and that light fades, not suddenly, not dramatically, just steadily, month by month, as the warmth that gave it a voice weakens. 3I Atlas is now far enough from the sun that its coma has begun to visibly thin. The chemical signatures that once shouted from Webb's spectrograph are becoming whispers. Every additional week it travels outward. The signal-to-noise ratio for every remaining observation gets worse. And there is a real hard limit to how much farther this can go before 3I Atlas becomes, once again, exactly what it was before July 2025. An invisible, cold, dark object lost in the scale of interstellar space, indistinguishable from the trillions of others we will never see. This is the part that should make you sit up. Because we are not talking about losing contact with a machine we built. We are talking about losing the ability to observe a physical object older than our own star. An object we will never get back, that will never come this way again, that is now passing beyond the reach of the most powerful instruments on or above Earth. And NASA knows it, which is why, in the last several weeks, an unusual level of urgency has moved through the teams still tracking this object. Every remaining observation window is being treated as precious. Every spacecraft that can still get a look. Webb, the aging Mars orbiters, the Europe-built JWST probe still processing data from its November 2025 flyby, is being tasked to squeeze out whatever chemistry, whatever spectral detail, whatever positional data it possibly can before 3I Atlas crosses into the range, where it becomes functionally unreachable. Because here is the number that puts this in perspective. 3I Atlas is currently receding at roughly the same blistering speed it arrived at, close to 250,000 kilometers per hour relative to the Sun. At that velocity, every single day adds millions of kilometers to the distance between this object and every telescope trying to study it. The window isn't closing slowly, it's closing at a pace that makes last chance not a dramatic phrase, but a literal engineering deadline. Let's talk about what's actually at stake in these final readings, because it isn't small. The methane to water ratio Webb detected earlier this year, 11 times anything ever measured in our own solar system, was treated by researchers as the most chemically anomalous measurement ever recorded for a comet. It pointed to a formation environment colder and stranger than anything in our own outer solar system. But a single measurement, however extraordinary, is still a single data point. Scientists wanted more. They wanted to track how that chemistry changed as 3I Atlas moved farther from the sun, whether the ratios held steady or shifted, whether the carbon dioxide production that spiked near perihelion would taper in a way that matched existing models or broke them entirely, the way almost everything else about this object already had. Those follow-up measurements are happening right now, in the final weeks before the signal effectively disappears. And what's coming back, according to researchers still processing the newest Webb and JWST data, is not calming anyone down. The dust production rate, how much material is still coming off the nucleus even this far from the sun, is higher than models predicted for an object at this distance. That matters because it suggests the nucleus itself may be less depleted or structured differently than any comet we've studied before. An object that should be running out of volatile ice to sublimate is still shedding material at a rate that doesn't match any comet formed in our own solar system. And then there's the question nobody has fully answered. How big is the nucleus, actually? Estimates from earlier in the year ranged wildly, from under half a kilometer to over 5 kilometers across, because resolving something this small at this distance, moving this fast, sits right at the edge of what even James Webb and Hubble combined can pin down with confidence. Every additional data point gathered in these final weeks is one of the last chances to narrow that number before it becomes unknowable for good. This is what NASA in panic actually looks like from the inside. Not chaos, not disaster. A quiet, focused, almost desperate effort by scientists who understand that a door that opened by pure cosmic chance in July of 2025 is now closing, and there's nothing in human engineering capable of propping it back open. Because, make no mistake, nothing is going after this object. The European Space Agency's Comet Interceptor mission, set to launch in 2029, is designed to catch a fresh, undisturbed comet from our own Oort cloud, not something already moving at interstellar velocity, already most of the way back out of the solar system. There is no spacecraft on any drawing board, funded, or even proposed that could match 3I Atlas's speed and catch it before it crosses back into the interstellar dark. Once it's gone, permanently. Not until the next flyby, not until the next mission. Gone, the way the first 2 interstellar objects we ever detected, Oumuamua and Borisov, are gone. Fading points of light that passed through told us what they could and vanished into a scale of distance that has no meaningful return. And here's the detail that turns this from a scientific milestone into something closer to a genuine loss. 3I Atlas is between 10 and 12 billion years old. It formed around a star that, statistically, may no longer even exist. It carries a chemical fingerprint of a protoplanetary disk from a different corner of the galaxy, under conditions our own solar system never experienced. It drifted through the void for over 10 billion years, alone, cold, dark, unseen. And then, for less than 2 years out of that entire span, it happened to pass close enough to a species with telescopes good enough to notice. That is the entire window. 2 years out of 12 billion, and that window is now down to its final weeks. Every scientist who has worked on this campaign understands what that means. This isn't a comet you study again next year, or send a probe back to in a decade. This is a once-in-the-history-of-civilization encounter with a physical object from outside our solar system, and the last usable data is coming in right now, in real time, as this video is being made. So what happens next? Over the coming weeks, the remaining observatories will squeeze out their final high-quality readings before 3I Atlas fades past the point of useful detection. After that, it will still be technically trackable for some time, using pure positional astrometry, enough to refine its outbound trajectory, enough to confirm exactly where it's headed as it leaves. But the rich chemical detail, the spectroscopy that told us about methane and carbon isotopes and radiation-age surfaces, that ends. What we have captured in these final observations will be, in a very real sense, the last chapter of the only physical sample we will ever hold of an object this old from this far away. Researchers processing the newest data have already indicated that the coming months, and likely years, will be spent working through everything gathered in this final stretch, cross-referencing it against the Webb data from earlier in the mission, checking whether the chemistry held steady across the entire outbound leg or shifted in ways nobody predicted, building whatever final model of this object's composition, and history is possible before the file is, for all practical purposes, closed. And when that analysis is done, whatever it concludes will stand as the final word on 3i Atlas, not because anyone chose to stop looking, but because the object itself has moved beyond the reach of the tools that made looking possible in the first place. Here's what I want you to sit with as this story closes. For 10 to 12 billion years, this object drifted through the galaxy in total darkness, indifferent to stars, unseen by anything. Then, for less than 2 years, it passed close enough to a small, curious species on a small blue planet that had only just built the instruments capable of noticing it. We pointed everything we had at it. We read its chemistry. We photographed it from the surface of another planet. And now, as it fades back into the dark it came from, we are watching the signal go quiet in real time. The last transmission, if you can call reflected sunlight a transmission, from something older than our sun. It will keep moving. In the early 2030s, it will cross beyond Neptune's orbit. In a few thousand years, it will cross the heliopause, the same boundary Voyager 1 crossed in 2012, and return fully to the interstellar space it came from, carrying a chemical record it collected over billions of years and briefly let us read. We had one window. We used it. And the last signal, whatever final data comes back in these next few weeks, will be the closing line of a story that took 12 billion years to reach us and lasted less than 24 months once it did. If this is the kind of story you came here for, the real data, the actual stakes, told with the weight they deserve, subscribe right now, because the next interstellar visitor is already out there and will be ready the moment it arrives.